Hello there and welcome to Lower 6 Maths A. This is the Applied Practice Paper F. Here we're working on question 7, a velocity time graph question. So, a racing car starts from rest at a point A and moves with constant acceleration of 11 meters per second squared for 8 seconds. The velocity it reaches after 8 seconds is maintained for t seconds. The racing car then decelerates from a velocity to 40 meters per second in a further 2 seconds, reaching the point B. Sketch a velocity time graph to illustrate the motion of the car. Okay, so let's look for what it starts with then. It starts from rest, so we're going to start down the bottom. Let's put some velocity up here in meters per second and time down here in seconds. So, it accelerates. So acceleration on a velocity time graph is its gradient. So here it has effectively a gradient of 11 meters per second. So that's every second that it goes on for, it moves up on the velocity scale by 11. And this happens for 8 seconds. So 8 seconds later, so time of 8, it's going to have a velocity of 88 meters per second. The velocity is then maintained for t seconds, so that's t seconds, and the racing car decelerates to 40 meters per second here, a further 2 seconds in. So this is at t plus 8 now, because this distance from here to here, or the time elapsed here, was t seconds. So at the next point here, it's going to be t plus 10. Let's go downwards 2 seconds later to a velocity of 40, reaching a point B. Sketch a velocity time graph. Include the top speed of the racing car in your sketch. Done that, 88 meters per second. Part B, given that the distance from A to B is 1404, find the value of t. Right, okay, so in that case, the distance travelled is going to equal the area under this graph. Now what I'm going to do here is split my graph up into 3 sections. Section A, Section B, and Section C. And this area here, looking at the dimensions on the time axis and the dimensions on the velocity axis, will equal 1404. So triangle A is going to be 88 times 8, base times height, divided by 2. So that's what we get for triangle A. Rectangle B, that's going to be 88 times t. And trapezium C here, now the average speed in between 44 to 88 is going to be 64 meters per second. And it's done that for 2 seconds. So 64 times by 2. So what I've got here is area B, area A, and area C, and this is going to equal 1404. Okay, what I'll then have is simplifying this to 352, add 88t, add 128 equals 1404, and subtracting this, divided by 88, and we get t is 10.5 seconds. Okay, so doing that final bit on your calculator there. Okay, so that's 8 marks for that question.